Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. Research design is a very important aspect of public health and for medical practice as well. Research definition: the scientific foundation of research, study design, and planning and management of research. These are the titles or topics that we will be talking in this lecture. What is the definition of research? Many definitions. Research is a scientific approach of gaining knowledge through investigating a research question to understand the new information coming out of this research. So we are gaining knowledge, investigating a question. We ask a question and we need answers. Other definition: any creative systematic activity undertaken in order to increase the stock of knowledge. It's almost the same: knowledge, including knowledge of man, culture, society, and the use of this knowledge to develop new applications. Better understanding of research can help critical thinking, problem solving, interpreting data, and communicating research findings. For clinicians, the benefit of improved research capacity and use of evidence-based approach for decision-making should result in better clinical care, safety, and competency. These benefits justify the integration of research teaching into. So, when we talk about research, we have to understand that it is based on science. It's not haphazard, it's not hearsay, it is a scientific method. So it's in general knowledge acquisition gained through reasoning, intuition, but most importantly through the use of. What is scientific method? Scientific method has been defined as a systematic, empirical, control, and critical examination of hypothetical propositions about the association among natural phenomena. It also includes elements of determinism and skepticism. Systematic. It is using orderly procedures to ensure reliability. It's not chaotic. Chaos. Logical sequence is used from problem identification through data collection, analysis, and interpretation. That's the systematic. Empirical, it means documentation of objective data through direct observation, so it's related to observation. Findings are grounded in the objective observation of phenomena rather than the personal bias or subjective belief of the researcher. So when you ask a person, he said, it's related, this is related to that. If this person does not come with an evidence or research to as an evidence for his saying, it is just hearsay. It's personal bias, personal belief. When you have evidence, proof based on research, it is empirical and it is used. Control. In order to understand how one phenomenon relates to another, factors are controlled that are not directly related to the variables in question. So you have to just study things as they are, but sometimes we use control. We control factors. We directly try to intervene. But in general, we need to understand how this phenomenon relates to another. So we try to factors are controlled that are not directly related to the variables in the question. Investigators have confidence in their research outcomes to the extent that they control extraneous influences. They would not allow bias to control their research. Critical examination of hypothetical propositions about the association among. Determinism, it's the notion that events occur according to regular laws and causes. The goal of research is to discover these regular laws and causes. Skepticism, the notion that any proposition is open to analysis and critique. That's what we. What are the steps in research? What it takes to conduct a research? We choose a question to investigate. We ask a question. We identify hypotheses related to the question. The question, for example, is smoking related to cancer? This is a question. Then this question we transform it to a hypothesis. We say lung cancer is related or associated with smoking or cigarette smoking. Then we make testable predictions in the hypothesis. We say that, as we said before, it's related. It's not. There is a relationship. There is no relationship. There is a difference. There is no difference. These are the terms that we use in prediction the hypothesis. Design an experiment to answer hypothesis question. Then collect data and experiment. Determine results. Assess their validity. Determine results, support or refute. Suspicion that a factor, exposure, may influence occurrence of disease or a noted health outcome. That's what we call the relationship between the exposure and the outcome, or the risk factor, exposure risk factor, and the outcome, health outcome, or whatever. So we suspect, then we ask the question, then we formulate a hypothesis. So observations in clinical practice, for example, it will give us such ability. Examination of disease outcome patterns. Do subpopulations have higher or lower rates? Are disease rates increase in the presence of certain factors? Observations in laboratory research also, and theoretical speculation with no field or no lab. We identify variables interested in. We divide them to two types, exposure and outcome. Exposure, the risk factor that or will predict the happening or the occurrence of the disease or the event. For example, the smoking that was happening before lung cancer occurs, it is a risk factor for that. Obesity and also other factors, lacking of physical activity is a risk factor for diabetes, for cardiovascular disease, and so on. So the outcome is the disease or any event that is predicted by this risk factor. So how we formulate the hypothesis? Frame a hypothesis which seeks to answer a specific question about the relationship between an exposure. Basic question in research: are exposure and disease outcome linked? Is there an association between them? Exposure, disease. Exposure. If we look at this diagram, at first sight we might see it's complicated, but it is about health as a decision-making problem as much as a healthcare or policy problem. Personal decisions are the leading cause of death. If you look at smoking, diet, exercise, drinking alcohol, doing drugs, take suicide, condom use, criminality, they are all related to smoking, more smoking, and accidents, binge overweight, alcohol use, unprotected sex, illicit drugs, suicide, homicide, and all these are what? The outcomes. So risk factors, intermediate risk factors, and then the outcome. Diseases of the heart, malignant neoplasms, cerebrovascular diseases, chronic lower respiratory diseases, diabetes, Next step, we design studies. A lot of designs, but mainly we deal with these designs: case series, cross-sectional, case control, cohort. So, outline of research plan. Elements are research question, background, significance, design, time frame, approach, subjects, selections, criteria, sampling design, variables, outcome, predictor, statistical analysis. The research question is the objective of the study. Background, why we are doing this study. Its significance, is it important, why we're doing it in this place, and so on, with such population. Design, how is the study structured. Design, that we will be talking and explaining. Subjects, who are the subjects and how will they be selected. Variables, what measurements will be made. Statistical analysis, how large is the study and how it will be analyzed. Research question, scientific foundation, research question. It is the objective of the study or the declared research, uncertainty or inquiry the researcher needs to get an answer for. So you begin with a question, you need an answer for that question. It should be concrete, focused, and around a researchable issue. Characteristic of a good research question: feasible, interesting, novel, ethical, relevant, should contribute usefully to our state of knowledge. F-I-N-E-R, finer, feasible, interesting, novel, ethical, relevant. Research question, as we said, it's the fundamental start of any research. Whether we develop a new question or build on a previous research findings, where ideas start to become research plan. Next step is looking for the available resources that could make resolving this question or otherwise redesign. How to design research question? First of all, we have to be good and excellent in mastering the literature. We go back to the past studies, previous studies, what the published studies on the topic of interest provides a powerful help in shaping the question. And this would require what? Scholarship, thoroughness, systematic review. All these things are explained that need to be understood. Being alert to new ideas and techniques. Researcher shows better quality among colleagues. Attending conferences, reading journals. Skeptical attitude, it does not mean that you have always to be skeptic, saying that this is not true, this was not, this is not. No. This is about doing research with trying to understand or make a question, can it be done differently or so on. Might question a non-scientific fact or prevailing practice, local, regional, global issue, might lead to developing a question. Observation of patients, phenomena, events, teaching, originality. Creativity is a major source of ideas, new methods, approaches, measures, indices, and tenacity, persistence in resolving the problem. Also, the characteristics are here as a finer acronym: feasible, interesting, and so on. Feasible, when we say the research question or the research should be feasible, it has an adequate number of subjects. Preliminary sample size calculation, we do that. Then account for exclusion and non-response, piloting, expand exclusion criteria, different design, multi-center, expand time frame. This is just to say, to know, is it feasible to have, for example, 100 subjects, 200, 1,000, 50, and so on. Has adequate technical expertise, hence to be able correctly to measure variables, get some training, affordable in time and money, strict the research to the available resources and time, be manageable in scope, don't collect unnecessary data, nor scope to stay focused on most important goal. Interesting considerations. The purpose of the study, why you're doing this. Answer an important question is interesting. See that the mentor or peers find it interesting, novel, contribution to the science field, may replicate previous study, different population, time period, improved measurements, risk factor, avoiding weaknesses of previous studies. Ethical, it should not breach any ethical principle. Principles of ethics are respect of autonomy, beneficence, non-maleficence, justice, and also it should go control for scientific misconduct, the authorship, and conflict of interest. Relevant, does it advance scientific knowledge? Does it influence practice guidelines? Does it influence health policy? Is it relevant to the specific research fields? Smoking. Is smoking associated with lung cancer? We stated as a hypothesis, we say smoking is related or associated with lung cancer. We say also about physical activity. Lack of physical activity is associated with type 2 diabetes occurrence, and so on. Then we come to the background as significance. It is the rationale. What is known about the topic under investigation locally, globally? Is the topic important, relevant previous research? What contribution will... Then we go back to the hypothesis. Testing hypothesis is related to study design, retrospective, prospective, compare groups of persons for difference in exposure or outcome. Hypotheses are tested for difference, agreement, dose response, similarity. This will determine the direction of testing. For example, the average of blood sugar is more in case group than the control group. This is one direction. But when we say it as two direction, the mean blood sugar is different between the two groups. Or we say the mean blood sugar in case group is different than the control group. So it is whether minus or plus, positive, negative, so it's two direction. Study subjects, specification of inclusion and exclusion criteria. We relate that to the study design. Variables, outcome and predictor. Predictor is the variable that occurs first and is more likely to be causal. Outcome is a consequence event hypothetically related to a predictor. It's a consequence of the risk factor. Analysis of data. Then we do the analysis, descriptive and associations. We measure the variables, measurements. We estimate parameters, rates, ratios, and we make some statistical association, the degree to which the rate of disease or outcome in persons with a specific exposure is either higher or lower than the rate of disease or outcome among those without the exposure. It will include statistical testing of hypotheses. It means how much chance alone may explain our results. Then we assess the validity of association. It might be a real association really exists, or there might be invalid association. Are there alternative explanation for the association? It might be due to chance, it's not real, due to a lot of mismanagement or measurement, bias, confounding. These factors might affect planning and management. The researcher should be careful about some issues: internal validity, external validity, and planning. The Internal validity means the degree to which correct conclusions are drawn about what actually happened in the study. External validity, the degree to which these conclusions can be generalized to people outside the study. So when you do a good and adequate planning of research questions, sample design, analysis, you will be able to exclude all erroneous or errors or keep the validity good. Then we go to research errors, two main kinds: random errors, systematic errors. Random errors, wrong results due to chance. You cannot control it sometimes. Source of variation that equal likely to distort estimation in both directions: good, bad, positive, negative. Systematic error, wrong result due to bias. Source of variation distorts estimation in one direction because you introduced bad data or other data that should not be there. Your measurement was wrong, and so on. So how we deal with errors: random error, systematic error, during the design, external validity, random error, solution. Improve design, enlarge sample size, increase precision. For the systematic error, improve design, increase accuracy of measurements. And for the implementation internal validity, do the quality control while you are doing the research or data collection, even before quality control and quality control. So now we present this table about the cohort studies, cross-section studies, case control, and experimental. This table is showing all the characteristics of these three studies or four types of studies. Thank you.